So you know by now that whenever we build a ramp, we need to build it to ADA standards. But how do we confirm that? You guessed it, we inspect it. In this video, you'll learn how to inspect a finished ramp to confirm it meets ADA and local standards. Of course, some ramps will have unique requirements, but this quick video will give you the basic techniques and principles to help you handle any situation. But let's start with the bad news. A lot of these guidelines are about numbers. But the good news is that you'll get most of the way there by memorizing just 3 of them: 2.0, 8.3, and 48. So let's start with 2, or actually 2%. In the first video, we talked about the 2 key parts of ramps, parts that go up and down, and parts that are level, where folks can rest without worrying about tipping or rolling into traffic. The 2% number is about these level parts. To be considered flat or level by ADA standards, that section of the ramp can't have a slope any greater than 2%. Anything above that won't pass ADA inspection. That's why all our ramp design maximums are 1.5%, so there's some construction tolerance. Next, the 8.3% number is about the other parts, the parts that take you up and down. Any ramp slope greater than 8.3% will fail ADA inspection because it's going to be dangerously steep for a lot of folks. And 8.3% is the absolute maximum. That's why our ramp design maximums specify 7.2%. So again, there's some construction tolerance. But more than 8.3%, that ramp's going to have to be torn out and rebuilt. Then lastly, 48 inches. That's the minimum width of any panel someone will normally use to get up and down on a ramp, whether it's level or sloped. That's so people have plenty of space to turn or navigate the ramp, something you can imagine is especially important if someone's in a wheelchair. So again, 2.0%, 8.3%, and 48 inches. All right. Now let's see these numbers in action as we walk through a typical inspection. First, clear the area of any debris that could give your level inaccurate readings. Next, grab a 24-inch digital level. Anything else won't give you precise enough numbers. Make sure it's calibrated before you start every inspection. Finally, where you'll put all this information. Using our PBOT ramp inspection form is easy, and it'll guide you through each part of the ramp and the measurements you'll need to take along the way. But you can also enter your data on the Survey123 app. Now, one of the first things you'll probably notice is that the ramp in front of you may not look exactly like the ramp diagram on the form. That's because, as you saw in the first video, there are a variety of ramp styles, and each has to be customized to its unique location and characteristics. So here's a pro tip on how to find A on any ramp. Start on the tactile dome at the bottom of the ramp and walk up. At the top of that first ramp section, you'll always find a level panel for folks to rest. The right edge of that panel will always be where A is. Once you have A nailed down, you can place all the other letters. From A at 3 o'clock, B will always be at 6 o'clock, C at 9, and D at noon. All right, back to it. So here's your first test. What's the minimum width and length this panel is supposed to be? That's right, 48 inches. But as you can see, this ramp is larger than that. So in addition to inspecting and measuring the entire landing, you'll also need to mark 48 inches from the grade break and measure there to confirm the landing meets minimum ADA standards. Now again, this part of the ramp is supposed to be level, or at most, 2%. And ideally right at our design spec of 1.5. To confirm that, you'll need to take measurements along the 4 sides of the panel: A, B, C, and D. On our form, you can see that the A measurement goes here, and so on. But hold on, if the panel is 48 inches and the level we require you to use is only 24 inches, where do you take your measurement? Great question. you take measurements every 24 inches and then record the largest one on the form. And by the way, always place your level within 3 inches of the joint, but never on the joint. Okay, that's A. Make sure you record it in the right place. Let's move on to B at the top of the ramp. Again, 2 measurements, saving the highest number. By the way, the width of B, the top of the ramp, should be the same as the width of the ramp below it. Next, C. Here, the landing is wider than the ramp, so take your measurement along an imaginary line extending up from the ramp's joint line. Taking 2 measurements, recording the highest. Then, D at the 48-inch mark, recording the highest measurement here. Now, move on to E and F, which are typically the upper ramp that transitions from the level panel you just measured up to sidewalk grade. E doesn't have a minimum length, but it absolutely can't have a slope of more than 8.3%. Then, move on to F, which does have to be 48 inches at minimum. Then move on to checking your levels. We just found out this panel's 64 inches, so you'll need to take 3 measurements with your 24-inch level and record the highest to make sure you capture everything. Next, F, which is the same deal. Take measurements every 24 inches until you've spanned the entire panel and record the highest. Okay, let's move towards the street and inspect the main ramp, starting with the length of J and K. Now make sure you take your measurement from face of curb, not the bottom of the tactile dome panel. Now, move on to taking your level down the ramp, every 24 inches, including the tactile dome at the bottom. What's the number this ramp can't exceed? That's right, 8.3% maximum. Again, our design spec is 7.2, but the ramp will pass if the highest measurement you get is still less than 8.3%. Once you get down to the tactile panel, make sure you place your level either on the surface between the truncated domes or on the domes themselves. Also, confirm it's the right color, federal yellow, and covers the full width. Now, all ramp panels are at minimum 48 inches wide. So just as you take measurements every 24 inches along an edge, here you'll need to take measurements 24 inches from the edge and through the entire panel. Finally, the other side of the ramp, or K. 5.2%. Looking good. While you're here, you'll also want to make sure that the plane of the ramp extends to the face of curb, so the transition is smooth for users. Place your level to span the tactile panel and the curb front, and check to see you don't see daylight underneath. Now, measure G, the face of the curb at the bottom of the ramp, taking care to place your level in front of the face of curb. Measure it twice along the length and record the highest number. Now, it's time to move on to the flares. If the flare slope is less than 10%, the flare passes automatically. But if it's more than 10%, it may be because the street itself is on an angle. So you'll need to factor in that angle or gutter slope. In most cases, you do that by deducting the gutter slope from the flare slope. For example, if you've got a 12% flare and the street itself is level, or a 0% gutter slope, 12 minus 0 is 12, which is greater than our 10% tolerance, and the flare fails. But if the street is on a slight hill, let's say 3%, you would deduct that 3% from 12%, giving you 9%, and the flare passes. You'll take your measurements just inside the joint lines and right at the face of the curb, and enter the highest numbers for each here. Once you're done with the first flare, move on to the other. Finally, the gutter panel or counterslope at the base of the ramp creates an easy transition to the street proper. First, we want to make sure it's 24 inches, which is our standard dimension. More importantly, we want that counterslope angle to not be too abrupt a change from the ramp angle. To check this, we measure our counterslope and add it to the ramp slope. Our tolerance is 11%, so if the total is under that, we're good to go. You can see in this example how smooth a transition it is. By contrast, if we increase the counterslope so the total is more than 11%, you can see how much more difficult this would be to traverse. That's why this counterslope would fail. This area at the bottom of the ramp is actually where there's any significant difference between perpendicular and diagonal ramps, at least in terms of inspection. Here, for safety, this panel is enlarged into a landing. So, because it's a landing, yep, it needs to be a minimum 48 inches by 48 inches, and with a slope no greater than 2%. As always, measurements every 24 inches. Otherwise, diagonals and perpendiculars have all the same parts and letters. But how about parallel ramps? Those look completely different from the basic ramp on the form. How do you inspect those? Well, here's another pro tip. Parallel ramps are perpendicular ramps without the ramp down to the street. Here's what I mean. Most ramp styles feature a ramp down from the sidewalk to a flat landing area, and then another ramp down to the street. Parallel ramps are the same, except they don't need that final ramp down to the street. That flat landing is already at street level. So for a parallel ramp, K and J don't exist. And that first landing, A, B, C, and D, is still a landing, but it's at street level. So when you're measuring a parallel ramp, you fill out the form exactly the same way, only without the J and K measurements. First, check the landing dimensions. 48 inches minimum, right? Make sure you measure A and C to the face of curb. Then, the slopes of A, B, C, and D, just like a perpendicular ramp. Move on to E and F, checking dimensions and then slopes. Then lastly, move to the other ramp and capture H and I. So that's how you'll inspect a ramp to ensure it'll pass ADA standards. So again, what are the magic numbers? That's right, 2.0%, the maximum slope for level areas. 8.3%, the maximum slope for ramps. And 48 inches, the minimum width for panels. Thanks for watching.